Hi, welcome back. This video is going to cover the topic of creating a multi-layer model. So we open up the PanMesh model building interface again under data preparation, well, reservoir and fluid description, numerical model. Click on numerical model. It pulls up the model that we had worked on in the introduction video, which is a rectangular reservoir 100 feet thick with a vertical wellbore at the center. Immediately that reminds me to show you that we can do something as simple as by clicking here on the move mouse mode, we can then drag the wellbore to wherever we wish within the reservoir body. As we move it, it is telling us the distance that it has moved and the coordinates to which it's moving. Note that up here we have a snap grid facility. If snap is on, any movements of lines or points or the wellbore are constrained to the coordinates here rounded off to 10 feet. I could have it round the coordinates off to 100 feet, and then we'd see that the movements are rounded off here to coordinates that are rounded to 100 feet. We can also choose to turn the snap facility off, which means that we can just move to any coordinates we wish. Note also that we can position the wellbore simply by clicking on the well configuration tab and setting the coordinates here to whatever we might wish, and the coordinates will have moved. So we'll leave that wellbore now in that relatively arbitrary position for the purposes of this demonstration, and we'll focus on the main topic of this video, which is to build a multi-layer system. Now, in the introduction video I indicated that under material properties in a basic model, when the interface is opened up, we have a single material property which is inherited from the underlying pan system model. We can create new materials simply by clicking on the new button here. So if we click on new, it creates a second material, and obviously this time we have no material properties defined. For simplicity, we might go back to material 1, copy those material properties, move forward to material 2, paste the same properties of material 1 into material 2, and then let's say we're going to want to model a material of much lower permeability, say 1 millidarcy, and we'll make it isotropic. So now we have two materials. We go back to our reservoir geometry, and we're still dealing with one layer. In order to add a layer in PanMesh, it is simply a matter of clicking on the node and layer configuration button, which opens the dialog box. We can then create a layer, an extra layer, a second layer, third, fourth, whatever we wish, in one of two manners. We can either click on this increment button here, which, as we see, adds a second layer with 0 thickness, and then we can manually add a thickness. Let's say we might say make it 50 feet thick, and we click on apply thickness to all nodes, which makes it uniformly thick 50 feet. So that is one option. The second option, so if I will remove that layer and go back to where we were at the start of this process, I can, once I've clicked on a column corresponding to a layer, I can insert a layer, and that inserts a layer for me of the same thickness and same material properties of the layer that I had originally picked. Now if I want, then I can change the thickness at that stage to the 50 feet. I can then choose to insert another layer, and you see it creates another layer, this time layer 3, which has the same thickness and material properties as layer 2. So let's say we want to make that layer 100 feet thick like layer 1. So now we have a 3-layer system. At the moment, if I close this box, in this view here, I see layer 1. If I click on this scroll option here, I see layer 2 and layer 3. Obviously, at the moment, all of these layers are of the same material property. So, how do we make layer 2, for example, into material 2? To do this, we have again a number of different options. We can either do it in the material distribution tab, which gives us a very simple option to just click on region 1, because we have only one region, and enter 2 as the material type. You'll see immediately that layer 2 or sublayer 2 is denoted or colored in a different color in green from layer 1 and layer 3. Okay, and the 1, the 2 and the 1 denote the material types in each of the regions and layer. So now if I go back to my reservoir geometry tab, and I click on this button here, which is color by material properties, because this is an easier way to distinguish between the materials. If I go now to layer 2, it's shown in green. To layer 3, it's back to being blue, which is telling me that layers 1 and 3 are of the same material type, and layer 2 is of the second material type, which is of lower permeability. So now I have basically transformed my simple 1-layer system to a 3-layer system, which is 2 formations sandwiching a formation or a layer, should I say, of lower permeability. Now this can be then run as a simulation, and we'll see what we get. We should remember that our wellbore configuration is setting a completion of only 50 feet, and now our total depth or thickness of reservoir is 250 feet. So if we run that, we come to simulation, PanMesh new run, we click on OK. We're going to run a simulation which is simulating 500 hours. And we pull up our model, and here we can see this model by default is shown in translucent form, so we can see into the reservoir. You'll see here in this region the wellbore. I can make the wellbore, the reservoir opaque, which more clearly shows the layering. I can click this option to use high contrast material colors, which are different from the default material colors that we use, and if we use that, we'll see it in the blue and green that we saw earlier. So we clearly have a 3-layer system. What we'll do now is revert to the original color scheme. So we right click for the context menu, we unclick use high contrast material colors, and now we just simply run the simulation by clicking on run simulation, or you can also press F5. So as we run the simulation, we get the response curve in a standard log-log plot. We can look or investigate a little bit further what the response is like. We click on the color contour option, we drag this green bar backwards and we see our pressure transient in time. What we might do is, again, as in the introductory video, we would click on isosurface, which shows us the radius of investigation, and we'll zoom in a little bit. You can zoom in by clicking, by holding down Shift and using the right mouse button and dragging forward and backwards. So that's zooming in and out. And if we come down here and we look at the progress of the isosurface, we can see some interesting things happening. If we put forward in time, we see that what's interesting is the isosurface isn't going down the full depth of the reservoir. And why might that be? Well, remember, we created a second layer in between the two layers of higher permeability, a layer of low permeability. So what's happening is the pressure transient is coming down and coming upon this layer, and we can see that better if we take a section. Here's one of the facilities within PanMesh. We can click on cut plane, and it cuts the reservoir in two. What we can do is, if we click out of color contouring, here we'll see that this blockage corresponds to the slowness of the pressure transient moving through this low perm layer. If we move the simulation on a bit further, see it's still struggling. It's actually hit this outer boundary. Remember, this model has the wellbore closer to this boundary edge here, and the pressure transient hits that before it gets through to the bottom layer. Finally gets through to the bottom layer. What I'll do is go to translucent, like that, so we'll see a little bit better. So we can see now there's our so this is the behavior of the radius of investigation because of the low perm layer and the effect it has on the derivative. So in this tutorial you have seen how to create a multi-layer system in the PanMesh model building interface, and here within the simulator you have seen how to use a cut plane to investigate the body of the reservoir in more detail, and also how to use the isosurface. So thank you for your attention in this video, and there will be more videos to come showing more of the features of PanMesh.